All right. Welcome, everyone. I'm Xandon Frogget, Senior FileMaker Developer at Portage Bay Solutions, and I am thrilled to be here today to talk about how we can leverage local large language models to transform our FileMaker development. I'm excited to share this, so let's jump right in and see why this matters. Why choose local LLMs? The answer comes down to 4 core advantages. First, you have enhanced security. Your data stays on your hardware, drastically reducing the risk of breaches. Second is cost efficiency. You can say goodbye to those unpredictable usage fees and embrace a more manageable and often lower total cost. And third is complete data control. You're in charge and you decide how your data is used and who has access. And finally, improved performance. Local processing means lower latency and reliable operation, regardless of the internet connectivities. These are the 4 pillars from the foundation of why local LLMs are a game changer for FileMaker development. So let's take a look at a couple of cool things you can do with large language models. So I've got a FileMaker solution here that I've got implemented, and I'm going to show dropping a image into a container field and then processing that image using a local large language model. So here we've got a screen capture that I'd taken. It's a PNG. I'm going to go ahead and drop that in the container, and you can see that image itself is an image of a table of information. And what I want to do is I'm going to ask the large language model, in this case we're using Gemma 3, to output it into a JSON table. And so we'll let it process, and it outputs it in a JSON table for us with all of the information that it got from the screen. Now we can then ask it to turn that into an HTML document, and it easily converts it over into an HTML document. And from there, we can go ahead and open that in a web viewer in FileMaker. So we'll open it in a web viewer, and now you can see the content where we have access to all of the data is now displayed nice in an HTML format, and all of that coming from the image that we let the large language model process. Next example, for me, we have here in the Seattle area, we have a grocery store called Metropolitan Market, and they have really good cheeses. They have a cheesemonger, and they have a whole bunch of varieties of really specialty cheeses from all over. And so I like to go in there and shop and get different cheeses. Here I've just taken a picture of one of the cheeses that I got, and I wanted to ask the large language model, what can you tell me about this cheese, and what does it pair well with? So it's just using that image going to give us that information and do some pretty cool stuff with it. So with that, you can see it gave it to us in an output format, and I can convert that into HTML and look at it. And now we can see in a really cool interface, we can see all of the information. It's a raw milk Manchego cheese. Gives us the information off of the label, the price. It's 12-month raw milk. About Manchego cheese, it's a protected designation of origin cheese, meaning it's made in a specific region, La Mancha, Spain, which is pretty cool. It's got some really nice flavor profile to it. Pairs well with Spanish wines and other reds, some fruits and stuff. Down here, the part that I like is it pairs well with honey. So if you drizzle a little bit of honey on it, it can enhance the cheese flavor. And all of this is coming back from the LLM based on the information that it got from the label, where it's using the information that it has access to as a large language model paired with the information that it's able to gather from the image. The next example that I've got here is an image of one of my kids' homework. We've just got some basic algebra, and we're going to ask it a question. What are the answers to this question? And it's going to take and interpret that from the image that I've sent. You could, of course, always type this out, but we don't want to bother with that. So we're just going to take the image and we output it into an HTML, and gives us a step-by-step how to solve this equation. So you can see here, step 1, we're going to distribute, then we're going to isolate the m terms and isolate the constants and solve for m, and basically gives us the answer. But it gives a nice breakdown, right? It's going through the whole process, and so we can do that at a complex level with just giving it some image data. And of course, you can always ask these questions, but being able to give it image data is really cool. Another example here. We have a company that puts a lot of product in grocery stores, and so they're always doing different marketing for their material. And it's really nice to be able to take information off of the packages that they sell, that they already have, and be able to just gather information off that to build information, right? in FileMaker. So here we've got, this is the back of a package of chocolate, and we're going to tell it to transcribe this image and give it back as output, convert it into JSON, and then create an HTML of it. So here we've got the output of it. It's a Seattle chocolate bar, dark chocolate, gives us the tagline, tells us the nutritional facts, all of this from that little picture, gives us the ingredients and manufacturing, company information that was on there. And because this is building into HTML, it's also putting in some additional things, like it's creating clickable links, like seattlechocolate.com website. It's also got the barcode that it pulled out. And so all of this, which is pretty cool, right? It's all done in FileMaker using a local LLM. And while you could do this with cloud-based large language models, you can also do this locally, so you don't have to be tied to those. So now you've seen some basic ideas for things you can do with local LLMs. Let's first understand the problems that we're facing with traditional cloud-based AI. So here's the crux. Businesses need AI, but cloud-based AI comes with some serious trade-offs, right? We're talking about compromising data security, losing control, and facing unpredictable costs. 34% of generative AI workloads in cloud environments are classified as presenting severe or critical security risks. A recent report in Generative AI and News states that 72% of IT and financial leaders agree that generative AI-driven cloud spending is becoming unmanageable. Let's break this down into 3 critical challenges that we're facing. First, we have data security. You're handing over control when you send data to the cloud. Second is cost and vendor lock-in. Pay-per-use can spiral, and it's hard to get out. Third is industry-specific problems. Every industry has unique needs, and a generic solution often doesn't cut it. To illustrate, let's use an analogy: renting versus owning. Think of cloud AI like renting. You have monthly payments, those are the costs. You can't make major changes, you don't have control. You have to ask the landlord's permission, which is a dependency, anytime you need to do something. And it's someone else's rules. These are restrictions that you have. And all of that versus a local LLM is like owning. You do have an upfront investment. You can customize it to your needs. You set the rules, and you have long-term cost benefits. This highlights how these challenges create a perfect storm. So what's the result? Companies need AI out of necessity, but there is a cost barrier, and they find it expensive and risky, so they worry about security. With things like vendor lock-in, they feel trapped. It's like the perfect storm. Let's take a closer look at data security. It's about sensitive data exposure, limited control, and compliance risk. Think HIPAA, PCI DSS. Violations are costly. And these aren't just the theoretical risks. Let's look at the real-world example. In January 2023, Yum Brands, the parent company of KFC, Pizza Hut, and Taco Bell, suffered a major ransomware attack that exposed personal information belonging to U.S. employees, including names and driver's license numbers. The impact of that, it led to the temporary closure of approximately 300 UK restaurants. These types of data breaches, they kind of erode customer trust and brand loyalty. The company has faced class action lawsuits from employees alleging privacy violations due to the breach, and this underscores the risk of sharing data with third parties. This leads us to a chain of concerns, including cost and vendor lock-in. Cloud AI presents a hidden trap. Escalating costs and vendor lock-in. You face high fees, complex cost management, little flexibility, and difficult, costly migration. Just imagine 100,000 calls at 2 cents each. That's $2,000 a month, only for API access. And that doesn't include data transfer, storage, or other fees. This creates a vicious cycle. You start with a provider, you build dependent systems, and then find it's too expensive and complex to switch. You're locked in. It's like building a house on rented land. Significant investment, but no real ownership. So now that we've established the risks to data security, the escalating costs, and the potential for vendor lock-in, but even if you could overcome those hurdles, there's another critical factor. the inherent limitations of a one-size-fits-all cloud approach, which it comes to the diverse needs of different companies. Every industry faces unique challenges when it comes to AI. Healthcare and finance have incredibly strict data regulations like HIPAA and PCI DSS, which is the payment card industry data security standard. Manufacturing needs real-time processing for things like quality control. Remote locations, they often struggle with reliable connectivity. And across many industries, the sheer complexity of integrating AI into existing infrastructure is a major hurdle. But local LLMs offer a powerful solution to each of these hurdles. For healthcare and finance, data sovereignty is key. Local LLMs keep data on-premise, ensuring compliance. In manufacturing, low latency processing becomes a reality, enabling immediate responses without relying on the cloud. And for remote locations, offline capability is crucial. Local LLMs function perfectly, even without an internet connection. And finally, local LLMs offer simplified management. You can tailor the solution to your specific needs and manage it directly without the complexities of cloud infrastructure. So while cloud AI struggles to meet these diverse industry needs, local LLMs provide a targeted, effective, and secure alternative. Let's finally unveil the solution. After that bleak picture, what is the solution? Well, local large language models, or LLMs. Why are local LLMs such a game changer? Here's why they work really well. You have complete data control that stays on your infrastructure. You have enhanced security. You have no third-party exposure. Improved performance, especially for real-time, and cost efficiency by eliminating the unpredictable costs. It's like having your own personal kitchen instead of ordering takeout. Let's quickly look at the performance advantages. Local processing eliminates delays, enabling immediate response times, and ensures consistent operation regardless of connectivity. It's like having your own chef. You have the freedom to customize, experiment, and avoid cost constraints, and full control of the environment, which is like owning your own workshop. Now that we've seen some of the why behind the local LLMs, let's get into the what. What exactly are these large language models? Here's a simple breakdown. In the cloud, the data is on their servers, you pay as you go, you have limited privacy, all of that versus local. The data is on your hardware, you have upfront costs, but you have full control and privacy. So with all these comparisons in mind, why should you specifically choose to host LLMs locally? The key benefits are, again, complete data privacy, no internet dependency, reduced latency, no API calls, you have full customization, and no content restrictions. These benefits work together with data privacy, enabling no internet dependency, which contributes to reduced latency, and so on, and so on. So let's look at some specific examples where local LLMs are making a real difference. Local LLMs are making a big impact. Hospitals are using local LLMs for analyzing patient records to identify treatment patterns. Banks are using local LLMs for fraud detection without exposing the data externally. Corporations are using local LLMs to search and summarize internal documents. And pharmaceutical companies are using local LLMs for early-stage drug trial data analysis. Finally, software teams are using local LLMs for code generation or review with proprietary code bases. Now that we've seen the why and the what of local LLMs, let's get practical. How do you actually set one up? Let's talk about the hardware. For entry level, you're going to want to have about 16 gigabytes of RAM to start. You need a good multi-core CPU, and you need a fast SSD. For more advanced solutions, the bare minimum is going to be 32 gigabytes of RAM and a powerful NVIDIA GPU. And if you're using an M-series Macintosh, you want to have plenty of RAM for that chip as well. As an example, the 70 billion parameter Llama 3 requires 32 to 64 gigabytes of RAM to run efficiently. Now for the exciting part, a live demo. I'm going to show you how to integrate FileMaker with local LLM. And we're going to use OpenWebUI and Ollama, make an API call from FileMaker, and display the results. Let's get started. So for this particular install, we're going to use Ollama. So we're going to go to ollama.com, and we're going to select the download that we're going to do. For this particular installation, this is an Intel Mac. I'm going to download the Mac OS installer. I'm going to install this natively. And the reason why I do that is on the M series chip, new Macintoshes. Installing it natively is going to be able to leverage the graphics card to be able to do the inference. So for this particular install, I'm going to follow that practice, even though normally I would use Docker for hosting. If it's on a Windows machine, I would use Docker containers to make sure everything's containerized. So we're going to go ahead and download the image, launch it, do our normal installation like we would any Mac app. Click next to install, and put our credentials, and that's it. And now it's ready to run. What we've got here is it's letting us know that the first thing that we can do is run this command in your favorite terminal. So we're going to copy this terminal command, and then we're going to put it into terminal. So I'm going to launch terminal, and we'll paste that in. What this is asking it to do is it's telling Ollama, the application we just installed, to run Llama 3.2, which is one of the large language models. When it does that, it's going to go ahead and download that automatically, since it hadn't already downloaded it, and take care of installing it. Now that it's installed, we can see we can start asking it questions, and this is through the command line interface, which is the default install for Ollama. So we can ask it to tell me a joke to test and see if it's working, and we've got one. Here's one. What do you call a fake noodle? And yeah, so it's working. The model's working. Now let's go ahead and, because if you're like me, yes, I like terminal. I also like to have a user interface to interact with that's a little more friendly. We want to have something that's going to make our lives a little bit easier. One thing to note before we jump to that is that when Ollama installs, it is going to install a login item that'll automatically launch at startup, so that it'll automatically be available. If you don't like that, you're going to want to make sure and remove that. But if you're doing this install, that's key, so that anytime the Mac restarts, Ollama is going to be running in the background. So to download the user interface to interact with the model and test and stuff, OpenWebUI was originally built and bundled with Ollama. It was part of the Ollama. But it was broken out shortly after into its own fork and managed separately. So, which is great because you don't have to wait for one to have updates in the other. So, so for this instance, we're going to go ahead and download that and install it. So I'll go to the OpenWebUI page, documents page here, and we're going down to, if Ollama is already on your computer, what commands are we going to use? And for this, I like to use Docker, because this is going to be a web interface that's going to be hosted on our machine, on this machine that I'm installing it on, and I want to control that and make sure that it's not spread out throughout my operating system. So, like I said, Docker allows you to containerize it and keep very control, and then if you don't like it, you can just get rid of the Docker container. But in order to do this install, we do need to install Docker first. So I'm going to go to docker.com, select Docker, and if you go to the front page and you're like, wait, how do I download it? You just scroll down, and down at the bottom is the download Docker. And Docker is free. There are certain licensing restrictions you do need to keep in mind, but for this particular instance, it is free and you can use it for hosting. So I'm going to download this for the Mac Intel chip, which is what I was doing this example on. But if you're doing Apple Silicon, you do that one as well. So we'll download and install Docker. And after it's installed, you can see it started running at the top. The next thing that we need to do is we need to capture that terminal command on how to install it in Docker. Now we can go ahead and open up a terminal and put that in. But because Docker's installed, we can actually just go to the dashboard in Docker and they have a terminal that you can just click on down here in Docker, and it's already referenced properly. So I'm just going to go ahead and paste my Docker install command in right there, and go ahead and hit return. And it's going to go ahead and install that Docker container with OpenWebUI, and everything's automatically taken care of. So now you can see the container has started. The OpenWebUI container is started and opening. We needed to give it a moment to finish its launch because it's launching the container. You can see there's no CPU usage. As soon as CPU usage comes up, generally you'll know that it started to run, and we get a green light on the left-hand side. So now it's running. To be able to go to that web interface, you can see we've got the ports there. We can just click on that and it'll open a web browser going to that endpoint. So now we're opening that endpoint in our browser, and you can see this is our first time running the OpenWebUI. We go through the Explorer. The first time that you do launch it, we do need to set up and create an admin account. And even though this looks like a website on it is all hosted locally on our machine. Whatever we put in here is specific to this instance, and so for creating the admin account, you do want to put in your important information. Make sure you remember your password. In this case, since we're using a container, if I screwed something up, I can always just delete the container, reinstall the container, and reset all this. But once you get it up and running, you're probably going to want to make sure you have that password so you can always log back in. So after the first login, you can see, great, everything's running. First thing we noticed on our first time launch, since we did use the command line interface to install Ollama 3.2, you can see it's already loaded in the UI as well. Ollama 3.2 is already there. So now let's go ahead and test and make sure that that it's able to interact for inference with the model. So I'm going to click one of the default prompts to just have it run. And this is on an Intel Mac. It's a little bit slower, so I'm just speeding up that process. This is actual real time now at this point, where it's giving the response back. And yeah, it's not super fast, but for testing, it totally works. So that is pretty much how to install Ollama as well as OpenWebUI and get the two connected. So now that we've got it installed, we can, in FileMaker, create a web viewer that actually goes to that exact same OpenWebUI interface, right? How cool is that? So we can now do it from within FileMaker. The first thing we need to do, of course, for FileMaker to be able to make API calls for FileMaker scripts is we need to create an API key. So to do that, we're going to go under our username, lower left-hand corner, go to Settings, and under Account, Show API Keys. And if this is your first time, there's a little toggle there to enable API keys. But because I've already done that, API key is enabled, and you then would just copy that API key. So I'm going to copy that. Click Save and close that up. Now I'm going to go into my FileMaker scripts. And in my FileMaker script, I set a global for storing those API keys, as well as the host address. So in this case, I'm putting that API key in, and then I have my LLM host address listed there as well. For the script that's going to actually make the calls to do this, the request itself is currently an insert from URL call. And for setting up what we need for the insert from URL call in FileMaker is we need to set some variables that we're going to pass into that insert from URL curl call. So we're going to do that first. We're going to go in here to create a data variable, and the variable for the data is going to be a JSON object. And you can see that an example structure of that JSON object down at the bottom of that, where we have the model is a Ollama 3. That would be whatever model you wanted to reference. And then the message, the role of the message is going to be user in this case, and then the content would be, create an essay about it, whatever it is you actually want to send to the large language model. For this particular example, I do have an additional line here. You can see under messages 0, we've got an image base 64 encoded. This is for multimodal models. We want to pass it an image from a container. In order to do that, you do just take your container take the file in the container, base64 encode it, and you can attach it in this fashion. So that's what I've done here is I had a variable called image base64 where I base64 encoded that container image, and now I'm just attaching it to this JSON as base64 encoded text. From there, we need to set the URL that we're going to pass into our insert from URL call. And then this, you have your host name and then API chat completions. You can always look at the documentation on the Open Web UI to see how the different calls are made. But I'm just structuring that as a variable so it's easy to pass into my insert from URL. And then the last phase is going to be the actual insert where we set the options for the insert from URL. In this case, we're going to use xpost. For the curl call, we're going to do a post, data ASCII, and this is where we insert that at data variable. Sometimes this is a hard part for somebody if they haven't done API calls using FileMaker. So I want to show this exactly as it is in case you needed to write this manually from scratch. You've also got the headers in there. And then I always like, you can see the very last line there, dump header is setting it to a variable response headers because we're going to get a dump header back that will say okay and have different information in it. And I always like to take a look at that to make sure that that response header is can be handled correctly if something goes wrong. So I put it into a response header variable. That's pretty much it for that. Then we can go ahead and set the insert from URL call. And that is how you set up the script to do your calls. A little bit more planning at this point is show you some cool things since we have the UI up and running. Having it in your FileMaker solution and having Open Web UI installed, we actually get some really cool benefits. In this particular case, we can add users to the account, just like we have an admin account. We can add users and we can control their access to this. So if we provided them either in the solution, they can come in here just like a ChatGPT or anything and ask questions of whatever LLMs that we want to provide for them. And we have full control over that. We create a group and give the permissions to the group that we want them to be a part of. We can do all sorts of settings to control different access and what models they have access to, as well as what they can and can't do. So we can really make sure that that they're working within whatever the parameters are for our company to make sure we're in alignment with our policies. We can also control the models that they have access to. So we can assign a model, the group that has access to the model. And with that, we can, if we want to, provide system prompt information to really put some bumpers around to help protect them, to help guide them, some guardrails. A good example of this in one of the videos that I was watching talked about this for a company. If you wanted to provide this so that anybody in the company, when they're logged into FileMaker, can ask questions of the LLM without having to have an API interface created. They could just go in here and ask questions and have full control. Another instance that I like is if you have a family and you wanted to, if you're like me, I pay for, I have my ChatGPT account, I have my Cloud account, I have my Gemini account, and I'm paying $20 a month or however much for each of those, and I can't share those with the family, right? But what we can do is, and as well as with all the local large language models that we're hosting, or it could just be the local large language models that we're hosting, is we can set up access to what models the users have access to, and we can control that access. So for my kids, when hosting my own local large language models, I can provide them access to specific model usage and control their interaction, as well as see their chat history and put some real strong guardrails in there, right? Like I don't want my kids in there to just have it do their homework. I want it to act as a tutor and help them with their homework. And so you can put that in as a system prompt to sort of put some guardrails on it. And you can do the same with employees, and you can so on and so forth. And you also have full control. So you're not just handing over access to the large language models and somebody can abuse it. You can really, really get in and as a company that we're going to provide it, provide some very clear, responsible access to a large language model. And in addition to that, if you wanted to give them access via API usage, you can give them access to even cloud-based APIs and so on and so forth. So it's got some huge benefits. As well, there's you can provide access for web searching when the large language model is accessing. It can have access to web search. It can do code execution, and there's different things, pipelines and databases that can be connected to your open web UI. And these are pretty cool. They're a little bit more advanced, so be sure check out. There's plenty of tutorials and videos, and it's constantly changing. So it's really some really cool stuff once you add this in to be able to work with local large language models using this as an interface. Okay, so now that we've gone through some of the interface for Open Web UI. Now I'm going to start with from scratch, if you hadn't already installed anything, installing a model. So I want to, in this instance, install a model. We're going to install Ollama 3.2, and you can see as I key it in there, it automatically creates the pull command down there at the bottom. So then I'll go ahead and select that, and it's going to go ahead and automatically download and install. So you don't have to use the command line to install models. You just need to know what models at all. And you can get a list of models from Ollama models. Just put that into your search browser, and it'll come up with a list of all the different models that you can pull. So now that we installed the Llama model, let's go ahead and test that really quick and make sure that it's working. To do that, we want to refresh the browser once, and now we can type in whatever we want. So tell me an interesting fact about the Roman Empire. And I'll go ahead and process that really quick and provide inference, and here's our output. Okay. So now we installed Llama 3.2. Let's install another model. I'm going to install Gemma 3, which is just came out a few weeks ago. It's a super cool model. It's multimodal, and I wanted to show you that really fast. So it's going to download, install it, and we'll refresh the browser. And now you can see we'll start a new chat. We've got Llama 3.2. I'm going to add a second one, and this is important, especially if you're building for FileMaker. You want to be able to test your different models. So as you're trying different models and figuring out what one's going to work, you can select multiple models, and so that's what I'm doing here. So we've got the first one is Gemma 3, and then the second model is 3.2. Now if I ask it a question, it's going to run that question to both models and give a response for both. So now I can quickly compare and see which one's going to give me the answer that I want, or what's going to be framed in the way that we want, right? So, and you can add as many as you want into that list and get some really, it's really helpful when you're trying to debug which model should I use for trying to solve problems in your FileMaker solution. Next, because this is a multimodal model, I'm going to drag an image down and put it into the web viewer. And I just grabbed an image, put it down, and I'm just going to go ahead and hit return. And this was an image of the Engage session that I presented on just a couple of weeks ago in March. And this is just an image. There's nothing actually here other than this image. So it's going to automatically, just as I'd shown in some of the others, it's going to pull that and give us information from the image and break it all out for us. So we've got the key elements, lets us know when it was, what it is, different pieces of information based on what it's able to gather. So that's where you can, with multimodal model like Gemma 3 or Llama multimodal models, you can have it do this inference. So pretty cool, pretty helpful. So that's our installation demo. So some key things about setting up a local LLM. For software, some popular models currently. I'd shown the Gemma 3, which came out just a few weeks ago. It's open source. It's from Google. It is multimodal, and you can send it images. It has 128 languages, so it works great if you're having to convert text of any kind from one language to another. Another good model is Llama 3. It's been out for a while. Comes in different sizes and has 128K context length. For popular reasoning models, some models that are working really well are, everybody's probably heard of it, DeepSeek R1, which is out. And there are some new reasoning models that just recently came out that might be even better than that, but they require a little bit more hardware. DeepSeek R1 comes in an 8 billion parameter, so you can run it in a 16 gigabyte GPU pretty reasonably. It's got a 64K context length, and some of that can be adjusted as you go through it. For other reasoning, QWQ is a really good model, but it's a 32 billion parameter model, so it's going to require a bit more GPU, and it's got a 64K context window as well. So now to deploy, FileMaker Server 2024 now comes with a package for installing a mini Conda environment that uses the Hugging Face TensorFlow framework. If you're interested in that, Whimdecourt actually does a really awesome installation of that. I would highly recommend checking that out. Ollama has an executable file that makes the install simple and supports Llama-based models. So whether you want to go with the Hugging Face models or Llama-based models. LM Studio is also a desktop app with simple installation, complete package including GUI. That's a good choice. GPT4All is another good one. Provides single binary installer and is geared for CPU-focused, privacy-concerned users. So lots of different options out there, and obviously the frontier is new. There's going to be lots of changes, lots of new cool stuff. Everybody has their opinions, but these are some good base ones currently at the beginning of 2025 that are working really well. So now let's move on to the heart of the matter, integrating these local LLMs with FileMaker. To connect, you need an API endpoint. FileMaker server package leverages the Fast API framework. Ollama provides a CLI configuration and API endpoint with its installation, with additional GUI and API key management provided by hosting an open web UI instance. LM Studio has an intuitive GUI with a built-in server mimicking OpenAI's API, and GPT4All provides a polished desktop GUI, CLI, and REST API endpoints that are all built in. With that, security is crucial. For security, generally, you need to keep 3 layers of protection in mind. You have your network layer of level of security, where you're going to need to create a secure perimeter using an on-premise hosting and VPNs to make sure that it's secure and you have a secure perimeter to protect everything. You're also going to want to manage authentication, so you need to verify the identities with TLS certificates and API keys. And then third, you want to have some data protection in there, like a Guardian module, using dedicated modules like Azure Sphere to encrypt and manage sensitive data, ensuring secure data processing and transmission. Now let's see how this integration can be used in real-world scenarios. So this is where it gets practical. You can implement intelligent search with natural languages in FileMaker. You can automate content generation for emails and reports. You can create natural language interfaces with chatbots. Like imagine asking, show me all the projects John worked on last month, and then email the results directly from within FileMaker. These are all things and just a few examples of things that you can do once you connect large language models to your FileMaker solution. But to make these work effectively, there are some best practices to keep in mind, of course. Some best practices are going to be tailor your LLMs, start small, iterate, and monitor them, right? You got to be careful. You don't want to just jump all in. And this brings about some benefits of enhanced apps, competitive differentiation, future-proofing. The return on investment for this, for developers, you have faster cycles, new revenue, happier clients. And for industries, we have efficiency, security, and cost savings. So let's bring it all together with some key takeaways. To conclude, local LLMs provide a powerful way to integrate advanced private AI into FileMaker. It's more straightforward than you think, and the impact is undeniable. I encourage you to explore the resources and join community groups. And thanks for joining me today.